Okay, so number 5, find the tangential and normal components of acceleration for the helix given by r of t. It's equal to b cosine t I plus b sine t j plus c t k. So again, let's find the velocity and acceleration functions. This would be negative b sine t I plus b cosine t j plus ck. And acceleration is negative b cosine t I minus b sine t j. So let's do our dot product. Multiplying these two together, we get b squared sine t cosine t minus b squared sine t cosine t plus 0. Those two cancel, so this is 0. What does that mean? That means the numerator for my a sub t, so my tangential component of acceleration, is 0. It's 0 divided by something, but 0 divided by anything is 0. What does that mean? That means my acceleration, the vector working in the tangential direction, is 0. Which means the entire magnitude of my acceleration. If one of them is 0, the other one is the entire magnitude of the acceleration. So all I should have to do is take the magnitude of my acceleration function, and that should be the other one. And in this case, that's the square root of b squared cosine squared t plus b squared sine squared t by squaring both of my components for the acceleration. We know cosine squared plus sine squared is 1, so this should just be the square root of b squared, which is b. So the entire force of the acceleration is going in the normal direction in this case. Now let's look at number 6 on the next page. The position vector for a projectile is r of t equals 50 squared root of 2I plus 50 squared root of 2t minus 16t squared j. Find the tangential components of acceleration when t equals 0, 1, and 25 root 2 over 16. So it's only asking for the tangential component. It's not asking for the normal. This is only a two-dimensional, but remember, to find the normal, we usually would use a cross product, but it's hard to do a cross product if we don't have 3 terms. So let's find our two derivatives, v of t, a of t. The first one should be well, our I component is constant, so it should just have a j component. It should be 50 root 2 minus 32t j, and then just negative 32j for acceleration. So looking at the dot product, it would be 0, because there's no I components, plus you have 50 root 2 minus 32t times negative 32, which is, looks like, I'm just going to leave it like that for a second. Now, we need the magnitude of v, though. The magnitude of v, though, is just going to be this thing, the square root of this thing squared, which is just itself. Now, this is why I'm leaving this the way it is. If I take negative 32 times that 50 root 2 minus 32t over 50 root 2 minus 32t, it becomes clear these cancel, and this whole thing is negative 32. It asks for the value when t is 0, 1, or 25 root 2 over 16. but it doesn't seem to matter. There's no t here. What that actually means is the tangential component of acceleration, a sub t, should just be negative 32 all the time, which means my normal component should be 0 all the time, because this is the whole magnitude here. And that's it for 12.4.